welcome back to another geometry video, everybody. In this one, we are going to talk about the last lesson of chapter 3, which is a lesson on finding the measures of angles in a triangle. So with that, we'll just jump right in. So the triangle angle sum theorem is something you'll probably be familiar with. Maybe you didn't call it the triangle angle sum theorem, but basically what it says is the sum of measures of the angles of a triangle is equal to 180. So if you add up all three angles of a triangle, it's going to give you 180. We're going to prove this theorem. In order to do that, we need to talk about how many lines can go through a point that is parallel to a given line. So if I'm talking about this point up here, how many parallel lines can I draw parallel to this one through that point? The answer is the parallel postulate, basically. Through a point, not on a line, there's one and only one line that can be parallel to the given line. So there's only one way to do that. We're going to use what's called an auxiliary line to help prove the triangle angle sum theorem on the next slide here. So we're going to do a proof. You can see that in this proof we have an auxiliary line drawn in already, PR, and that is parallel to AC. And we're obviously given triangle ABC. What we're trying to prove is that the measure of angle A down here plus this angle 2 plus the measure of angle C has to be 180. And the way this is going to work is because we're using algebra, this can represent any type of triangle because the setup is always the same regardless of what shape the triangle is. So here we have our given. So PR, line PR is parallel to segment AC. That's given to us. And here we have the measure of angle PBC. That's right there. And angle 3 is equal to 180. What type of angles are PBC and angle 3? Hopefully you're able to answer with a linear pair. And the reason why they're equal to linear 180 is because, linear pairs are supplementary. All right. And then we have the angle addition postulate. Now, what I would like to be able to do is say that 1, 2, and 3 possibly add up to 180. But what I can do is I can break PBC, right? This bigger angle PBC, I can break it into 1 and 2. And I believe that's what the angle addition postulate is getting at. So we're going to say the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle PBC. And then you can see that basically PBC is getting substituted with that measure of angle 1 plus the measure of angle 2 in that next line. So this is going to be substitution. Substitution, I can spell. Evidently not, because substitution property. So I replaced the measure of angle PBC with the measure of angle 1 and plus the measure of angle 2. And now what I can say is, since I know these lines are parallel, I know that these measures are equal. The measure of angle 1 up here, I don't know why I'm here. Let me get rid of that. Measure of angle 1 up here is equal to the measure of angle A. Well, you ask yourself, what type of angles are those? The same goes for angle 3 and angle C down here. We have parallel lines and a transversal. They're on opposite sides of the transversal and in between the two parallel lines. So those are alternate interior angles. And we know that alternate interior angles have to be congruent. So we can just say the AIA theorem. And now we can just do a simple substitution. Let me bring this back up. My handwriting's so much nicer when I'm zoomed in. So we can say that the measure of angle A, because we're replacing angle 1 with angle A, plus the measure of angle 2, plus the measure of angle C, which is, right, we're taking the 3 and replacing it with the C. That has to equal 180. Sorry, I can't fit it all in one line. That's via a substitution. And notice that is what we were trying to prove, that no matter what, A plus 2 plus C, the measures of those angles have to equal 180. And this works with any triangle because of the setup that we had. All right, so that's the proof of the triangle angle sum theorem. Basically, all angles of a triangle have to add to 180. So let's do a few examples. So here we want to find the measures of angles x, y, and z. So first of all, it's probably easiest to find x first by using this. Let's try to make that a little thicker here. So in green here, I have a triangle. I know that those angles of that triangle have to add up to 180. So what I'm going to do is I'm going to take the 43 plus 59 plus x has to equal 180. Now, do you have to set up an equation like this every time? No. Basically, you can do 180 minus 43 minus 59 if you want. I like to set up the equation just to be thorough. Sorry, 102 plus x is equal to 180. If we subtract 102 from both sides, we get 78 degrees. So x is 78. That helps us find what y is, because if you look down here, x and y form a linear pair. So that means that y has to be basically y plus 78, x plus y, and x is 78 has to equal 180. We can just, we get 102 again. So 102 degrees for that one. And then last but not least, we can find x. I'll change colors again just to make it a little bit easier to see. So we have one more triangle. Yeah. There we go, that's a little better. All right, so I know that that triangle also has to add up to 180. So what I can do is do 49 plus y, which we just found was 102, plus z has to equal 180. That's a weird z. All right, so add those together. That's 151 plus, let me make that z a little bit better. And then subtract 151 from both sides, and we get z is equal to 29 degrees. So there's z, there's y, and there's x. All right, so just using the fact that triangles have to add up to 180. Let's try an algebraic one. So here we want to find the value of x. So I see that there's three angles in here. There is obviously that one, and that one. Remember that that little box means that that has to add up to 90, or that is 90. So we're going to have 8x plus 2 plus 9x plus 3 plus 90 has to equal 180 degrees. Combine all the like terms, so we'll take the 8x and the 9x to make 17x. 2 plus 3 plus 90 is 95. So we combine that and set it equal to 180. Subtract 95 from both sides. We get 17x is equal to, what is that, that's 85. And divide both sides by 17 here, and we get x is equal to 5. It doesn't say to plug it in. We could get a numerical answer for each of those angles, but it just told us to find the value of x, so x is equal to 5. All right, let's try one last one with this, I guess, algebraic one. If you'd like to try it, you can go ahead and pause. I'm just going to keep going. So this one's a little bit different, but not really, right? We're going to add up all those three angles and set them equal to 180. So there's the first two angles, and then we also need that third one. Add them all up, set them equal to 180. Combine your like terms, so that's going to be 8x. The 13 plus 7 is going to be 20. If we subtract 20 from both sides, we get 8x is equal to 160. Divide both sides by 8 here, we get x is equal to 20. Doesn't say to plug it in, so we're all done. We got x is equal to 20 for that. You could always plug in just to double check your answer, but I'm not going to do that on this video to make it even longer. All right, the last thing is a vocab and then another theorem. So when you have a triangle and you extend a side, so in this case I've extended this side here, right? I've made it a little bit longer. Anytime you extend a side of a triangle, you create an exterior angle. An exterior angle is just what it sounds like. It's an angle on the exterior of a shape. It doesn't have to be a triangle necessarily. But the exterior, when you have an exterior angle, the two interior angles that are not right next to the exterior, so this would be right next to the exterior angle, the two in a triangle that are not right next to it are called remote interior angles. 1, 2 over here are remote interior angles. The way to remember that is like the remote, they're like far away. Think of it like a TV remote. You can change the channels from far away. So they're far away and they're interior. That's a good way to remember it. The reason why I bring them up is there's a theorem that deals with these. Triangle exterior angles theorem says an exterior angle of a triangle is equal to the sum of the two remote interior angles. So if you look at this up here, angle 3 has to be equal to 1 plus 2, the measures I'm obviously talking about. We can use this to find different measures of a triangle. So in this one, if let's say we want to find the measure of angle 1. So angle 1 is a remote, it is an exterior angle. We can find the length or the measure of it in one of two ways. I could find this angle and then subtract from 180, or I can just use the triangle exterior angles theorem to just add those two up. So the measure of angle 1 is going to be equal to 80 plus 18. So that's going to equal 98 degrees. We can also use the triangle exterior angles theorem to find what angle 2 is. And I should say we can use it to find a remote interior angle as well. So in this one, I know that 124 has to be equal to these two added up together. So 59 plus the measure of angle 2. Obviously, that's what we're trying to find, so I'm going to subtract 59 from both sides. And I get, what is that? Just double check. 65 degrees for the measure of angle 2. All right, so that's what you can use the triangle exterior angles theorem to do. I believe that is the last slide. So I'll send you on to your homework, the homework assignments, Math Excel homework 3.5. It's the last homework of chapter 3. If you have any questions, you know how to reach out to me. I'll be available at office hours during the week, 1:30 to 2:30. Thanks for watching and have a great day.